Hi guys. So some of you may have watched the video clip I posted up a couple of days ago of the video overlays, all done using green screen but generated using equipment I'm working on, and decided that we're going to go with an architecture where you have a base unit and you plug in the modules you want. I've already changed my mind on the way the modules are going to work, but I need a module to test with and to work with, so most likely this one, which is going to be the mains one, will stay the same. So we're going to build this today and get it all together. Now I need to make you aware this is a prototype, this is not a production type setup, so there are compromises I'll make here that wouldn't be made in a production product. Mostly some of it being to do with I know how this is going to be used and I have control over it, so I don't have to quite be so careful about looking out for stupid. So what we've got here is all the bits that I'm likely to need to do this. I've got heat shrink, ferrules, ferrule crimp tool and other stuff that I'm going to need, as well as soldering iron, solder, so we're all good to go. So what has to go in here is we will use an SSR to switch our mains. We have a PZ EM04T, which is gaining all the information about our mains, and then we've got all the bits that go with it. The connection back to the control unit will be via this I think it's an M12 connector, commonly used on sensors and things, and we're literally going to slam this together. I will admit I have cheated. I have crimped this awful JST connector beforehand because I don't want anyone to have to watch me doing that. So what we're going to need to do is get this relay secured, work out where we're going to go with everything. I think my most likely layout is going to be something like that there, which keeps all our mains down one end. Obviously we're going to have cables running up and keeps everything in the base. I need to think how we're going to mount this without resorting to hot glue, and I'm going to pause you for just a second and try and work out what that awful noise in the background is. So my concern here is how close everything down here is going to end up being. I'm not especially happy about that, but I can't think of any way of putting this together that wouldn't. The alternative would be to take a couple of these out and attach this in the top like that, and again we've got the main sort of stays down together with the mains, and there is enough clearance for that to work. But I think on balance I'm going to find a way of chucking this in like that, and that should keep everything nice and neat, keep all the mains wiring down here. So what we've got to do regarding the mains is actually quite simple. We have a normal UK single socket extension here, and we are quite literally going to do somewhat akin to that. So we need to break into the live because the live's going to feed our SSR, and we're also going to need live and neutral to that, so we're going to have to break into the neutral and we'll carry the earth straight through. I realise I have only brought one Wago over here, so I think the first thing we're going to need to do is get these things secured in these positions. We'll probably come back and do that. I don't think I've got any. There'll be another way of doing it. I haven't got the heat shrink that big. I do have 3D printed cases for these. That sits in there. That sits in there like that. But again, there's just no room in here for this. One option is we take those terminal strips off and mount that in there, which probably isn't a bad shout actually. And then we can hardwire everything. I think we might actually go that way. So the first thing we need to do is get the SSR in and work out how we're going to do that. I think we've got a reasonable amount of thickness, so I'll just pop some screws in through there and see how that stays put, and we'll go from there. So I'm going to go do that off screen, mainly because it's going to be loud and obnoxious, and I'll bring you back when we've got some screws in there. Right, holes drilled, decisions made. I've removed that connector from there for now, so we're going to put that in there, we're going to put that in there. You may see that there are no holes drilled in there, that's deliberate. I'm going to put a pad under that, but it keeps the mounting hardware away from these mains connections. We have our hole for our connector there, so yeah, I think what we're going to do is we will pop the first fastener in. These are all countersunk. Need longer screws than that. That's because I'm looking over the top of the screw box. And we'll put this top one in for now. So we've got our DC contact on the SSR facing up. Just get that nut started if you can. Another one goes to line. So this nut and bolt just go straight in as they are. I'm not doing anything special or different with them. And we're just going to go finger tight for now. That's all we can get in there. That's in there. Right, before we go nuts with that, let's just make sure we can get this JST connector through, because I think it's going to be easier to wire this before. Yeah, okay, so we can work out what we need to do here. We'll get him in. I'm going to put a pad underneath that. I did have some, but I think I put it away. So I want that in a bit. That is actually Velcro. I did have a blade to hand, which I now don't, so I need to go and get some. Oh, yes, I do. So I'm just going to put a small amount of this under this board and trying to avoid the majority of the mains. Pop that there, and then that will sit in there like that, and that gives me a way of arranging it to work out what I need to do. I should have a couple of loose bits of wire, which I do there. So we're going into that, and then that is just literally going to come round like that. So all of this is extra. We then need to come into there for our SSR, and we'll use our orange here for the positive for the SSR. And that doesn't really have to go very far at all. We've got them. We need to put some ferrules on then. I didn't bring the crimp tool over, make a stripper. Just go grab it. So we'll just strip these off like so. Move those to one side for a sec. Hopefully they won't land in my coffee. We're going to use ferrules on these. So these are little almost like crimps, and they go on the end of your wires. Bootlace ferrules they're often called as well. You crimp them down and they give you a good solid connection onto those wires. You use them mostly in industrial settings where you don't want stuff moving around. Let me just grab the tool. Well, you can see as I squeeze the tool, put it over something contrasty, you can see the centre closes down. So we'll just pop those in there, and there you go, you've got a good solid connection there. Do the same on this one. And we'll do all of that on the mains cables as well. This is where I didn't actually get a screwdriver out because I'm an idiot. So So our negative is going under there. And we'll stick all of these through the hole, where I'm probably highly going to regret this. I'm highly probable I'm going to regret doing this. Let's just chuck this one in as well, like that. I'm just really checking my lengths here. They're good, so once they're on the connector they'll be fine. So we can wire that up in a second. Now we need to do this mains cable. So what we're going to do is simply find the middle of this and go straight through it. So we've now got a socket and a plug. And we're just going to strip down some of the conductor on this. Cool, right, that's that. This is our incoming, so this needs to go through here. And what we'll likely do is stop it about there. So I'm going to tighten that gland to clamp it and work out where we need to go. So our neutral can go up that side. Our earth can go up that side. We're going to bring an earth back down onto here. And then our live goes there. So let's prepare these ends. Undo this. Bear with me a second. Nothing like being ready to do the job. Let's just adjust that strip on there. So we want just enough on that one for a ring crimp, and what I'm going to do is just pop off one of these screws and make sure that our ring crimps are going to work. What I would do if I can get into them this isn't a brand new packet. No. Pop those over there so I can launch them everywhere in a minute. And yeah, we're good on that. So fairly standard crimp tool. Just get that live crimp down. And then these are going into Wagos. So we take a little bit more off of them. I did have two Wago connectors over here. You can currently only see one. Ah, there we go. Neutral in there, earth in there, and then we're going to need to sort that earth out as well. Got a bit of earth wire here, so we're going to go in to a ring crimp again. And we'll just crimp that one down. This is what I'm going to pay for not leaving enough space. So we're going to go in that with a slightly longer bolt than we used on the bottom. And then our crimp goes down on there. And what I forgot on the other side, which I will go back and chuck on, shake-proof washer, and I'm just literally using whatever I've got to hand to get that on there. And we are going to go if I can get one in there, which I'm doubtful of. No. I did want to go in there with a lock nut, but I don't think I can get one in there. So let's just get this started. There we go, that's started, and we can just spin that up, and we'll tighten all of these up before we're done. Right, we can pull this back now, reclamp it. What I'll probably do is just in here chuck in a cable tie. So our earth cable wants to go that way, that's absolutely fine by us. So we will also take our new earth up in that direction as well. Trim that down. And pop that into that Wago. So the only earth we've got left now is the outgoing earth. We'll bring that round here for now to keep it out of the way, and then we can chuck our live conductor in, and just make sure you can see there that that's going to clamp down on metal. It's not going to clamp down on the plastic sleeve of the crimp. So what we'll do is we'll tug that down a bit as it goes in, and we can see that that's biting down nicely. Again, everything will be tightened up, so I'm not too worried about it now. So we need, wherever I put it, the socket end. So we need to do the same thing again with this. We're going to need a fair bit of extra cable, so I'm going to come down and round like this. So we're actually getting quite a bit of extra cable here. So we've got our cable there, that looks like it should be good. So we feed that through. We won't tighten that down just yet. So we've got our two that we're not going to use. If you're wondering why I'm using a three-way on the neutral, that will become fairly obvious in a second. So we're going to bring a neutral down that side. Sorry, we're going to bring the live down that side, and the other guys can come down here into their Wagos. Let's try and get our cables cut to a good length. We don't want miles and miles of gash cable in here. So for our earth, that's it, we're done. There's nothing else to be done with that Wago, so we'll just tuck him down there. Our neutral we're not quite finished with. To be fair, we're not done with our live either, I nearly forgot that. I'll just tuck him out of the way for now. I think we can go that way like that. And that's those two taken care of. And then we're coming round and on to this live terminal. So we don't need to strip back quite as much. I like to work close into myself, and obviously recording videos like this doesn't really lend itself to that. And then this one goes exactly the same as the other one. Obviously there is weight on the cable which keeps pulling it back. So you want that sat properly, and just tighten that up. And as I said, I will go through and tighten all these up the way they should be. Right, we have some smaller mains cables we need to deal with now, and these supply the PZEM04, so we'll just strip them off. So the brown live is going into another ring terminal, and this is our third neutral conductor, so that will go in there. So what I'm going to do is chuck him in for now. So I think I've been sabotaged by my camera, so I will get you to where we're going. So we've sorted out the PZEM04's main supply. I am now just putting the current transformer on, and as I was explaining, where you put this current transformer depends on what you want to measure. So if you put the current transformer before the solid state relay, you will measure any quiescent current of the relay plus what power this draws. Or you put it after, you're only measuring your load. Now this one is going in after, so I wouldn't see any issues or any parasitic power draw from this PCB or from the SSR, which there can be some. There we go. It was my hot gun making the noise. So we squeeze all this back in and we're done with mains. What we'll do is we'll take our signal connector off. So our neutral goes in there. We feed our live through there, and that can go back in. Doing things that involve a lot of wiring, especially heavier wiring like mains, in a small space is not necessarily fun. So that's in. We're going to come back over to our live here. And we're going to use a little trick here. So if you go onto a terminal with multiple eyelets like this, you've got this situation where you can't put them on top of each other, or if you do, they end up stacking up like that. We don't have enough space to really go that way here, so what you do is you put the eyelets back to back like that. I don't know if you can see that. The eyelets will sit flat, they won't take up any extra space, and they won't try and leverage themselves away from the contact surface of the terminal. So just get them back in like that. Again, we'll pull them back just to make sure that we're biting on metal and not plastic. Right, so all our mains is done. So what we'll do is we'll pop those two at the bottom like that, and then we'll have the earth in that way, the neutral can sit in that way, and we just pull them round like that out of the way of everything. What I'll do is once we're assembled and tested, I will probably get rid of this loop that's over here, pull these back a bit further, and then hot snot these down. What I may do is assemble this with a piece of foam or something in there. Right, so that will now go down in there. So what we need to do is make these up. So we've got a couple of these that are going to be slightly difficult. You just want a little bit of extra copper on those negative wires, because we're going to twist those together. I turned the soldering iron off, which was a mistake. Have some coffee while I wait that to warm up. I hope the camera hasn't lost too much. While we're waiting, we'll strip these down. Don't need quite so much conductor on these. So something my electronics tutor said in college, and I found has been borne out in the real world, is there is something weird with the dye, green dye used in wiring, and for some reason it melts an awful lot quicker than anything else. Trim that one down a bit. So our first job is to tin these. We're at temperature. And with thin wires like this, you want to be as quick as you can be anyway. And we'll just get this orange down here. That orange has gone pretty badly as well. And then we'll just trim back. So the orange melted fairly badly, the yellow did, red's good, actually the green's good, and our black's good. Just grab some heat shrink for these. So we've got live mains kicking around here. There is no way in hell that we want any risk that these are going to come apart, or if they do come apart, they're not going to touch anything. So good lumps of heat shrink on all of this. We've got 5 conductors here. Go. Might need to use different ones for the black. So red, green, yellow. I'll go over what these will do in a minute. Can we get away with the black? I don't think we can. No. Orange. We'll just get something a bit bigger for the black. Bigger than I want to use, but it'll do. There we go. Right. So pin out wise, I didn't bring anything over to write on. That was silly. Nothing is set in stone here. So what I'm going to do, because it's easier with these to do it this way, is pop connector in, and then we end up, yep, so these match these pins here, and these have numbers on. So number 1 Where are you, number one? Number one is that pin there. So what we'll do is we'll mark that there. It's 1, 2, 3, 4, 5 in the centre. Right, so we're going to use the centre as our ground, and then we'll go VCC, RX, TX and the relay control. So what we've got coming through here is obviously a ground. We've got VCC, which is 3 or 5 volts. We have an RX line, a TX line, which I need to check on the PZEM, that might not be right, and we've got our relay control line. So what we're going to do is just quickly tin these connections. Yes, I do have a pair of helping hands, but actually I prefer normally doing it this way. Where you get to watch me make a complete hash of it on camera. So I've done an awful lot of these connectors and they rarely give me trouble. So what I'm going to do first, because we've got a big glob, a big heat shrink sleeve on there, is get that centre pin in, and then we can get the heat shrink on and we're done. I'm going to have to give up here and grab the helping hands. Go. And we'll slide him into the middle. Right, this is going to get a bit loud. I'm going to move you, and we fire up the heat gun. Bit much. Right, so we can work round now. So we're going clockwise. Double check that we are going clockwise. So, yep, we're going clockwise. So our number one is here. 2, 3, 4. So let's start on number one, which should be VCC. Make sure your solder's mounted, and these are like bucket contacts, so you need to make sure you get your wire right into the contact. I'll just double check that we're going the right way. Yep, so it's that one next. So it's anti-clockwise on the plug, and clockwise on our bit. I think they're quite wide enough to grip the whole thing. So next up is RX. RX is next to 5 volts, so that's green. Okay, get the contact nice and hot. Make sure you melt the solder. Add a little bit more solder if you have to. And then make sure your wire goes right into the bucket. Also, make sure that your bits of heat shrink are still on there. I've just noticed yellow's isn't. So that would have been upsetting. Just rotate around again. A bit extra. I know I'm working right at the bottom, sorry. And again, make sure your wire goes right into the bucket. And our last one, which I think I can get from here, is our orange which is the relay control. And we're in. Slide all our heat shrink down. What you want to watch out for doing this is that you get too much heat into the wire, which will cause your heat shrink to actually shrink onto the wire and you won't be able to pull it down. There's a yellow there. Right, noise again. The hope is that if anything goes wrong now, then it's going to pull out the entire chunk of heat shrink. Let's just get this nut off. We should now be able to get everything we need through this hole here. We can then guide our nut back over all the wiring. And then, assuming we can get everything lined up, get the nut back on there. And then we're on. Right, so we're getting a bit busy in here now, so we're going to chuck our positive terminal under there, our negative terminal under there, and we have control of our SSR now. Now, as I said, we're getting a lot of wire in here, so I'm going to guide the mains cable through a little bit further than it needs to be. And we need the other box of screws. So these are M3s. And I'm going to go with 3 M3s, which I'm getting low of. I use a lot of them. And two M3 nuts. Pop that to one side for a second. And pop those through from the bottom. Get our nuts. Bit of a concern. I'll have to be careful of that. So that nut there, that bolt there is very, very close. I think we'll be okay, but that's very close to the point where it probably wouldn't have been possible to get the PCB over the bolt. And that's because I didn't actually measure anything before I drilled that hole. Do the same with the other one now. Now what we're going to try and do is manoeuvre this in and get it down onto those two upstanding bolts, which is going to be easier said than done. We also need to get that connector in, like that. So we get one on. We might need a little bit of help just to get this one into the right place. There we go. And we can slide our circuit board down, pull everything back so it's all nice and neat. And we've already got a problem. We've got a crimp failed. That's annoying. Part of me wonders if we should also have just soldered those direct to the board, to be honest. But I'm going to go and correct that and I'll be right back. Right, so all that's really left now to do is to tighten nuts and bolts, tidy up in here, and then we'll test it. Now, I don't quite know how we're going to test it. In theory, I have a device that can be driven by this, so that's good. But what we're going to do is get some cable management sorted out in here, tighten all the nuts and bolts in, and just generally make sure everything's going to survive being given a good pull. And then I need to make a data cable up to go to my test board, and obviously our data goes on there. So basically that's a complete power measurement system and a remotely controlled switch. So you'd use that if you were doing load tests, power cycling tests, power up, power down tests and things like that. The idea is I want to build lots of these boxes with different things in. Now this is a PZ-EM04. You can talk to this with Arduino easy enough, or ESP32, STM32, whatever you want to use. There's enough information on it. This is using RS232 serial and one GPIO line. I think the plan is with these going forward is I'm going to switch this interface to RS485 on all of them. So I had initially thought, well, I'd have a couple of devices that could be connected over RS232, which would have the same pin out, and you'd select the device on the controller. The way I'm going now is possibly more towards using our own bus system, which means these will need to be smart. And it also means that for devices that interface with, say, I2C, that their life talking to them is a little bit easier. And what I likely do it is you ask for data channels, and then you need to know what that device is to return the data channels. So yeah, but I'm going to tidy this up and finish it now. I'll bring you back in a little while when it's all connected up and I have it pulling data, and then we'll see how well it works. Anyway, take care for now. Back in a bit. Right, so we're all built up and working. There's the box. There's a really rough prototype, and here's a lovely old piece of equipment. This is the Power Supply for radio teletype. I've done a quick short on it, and I figured that would be a really good test for this. So we need to turn this on. So we need to make sure you can't really see it, unfortunately, the lighting's horrible. We're turned off there. So we've got our relay that controls whether we're on or off. We need to move that into the on position. That's now on, and I will switch the data overlay on in a second, but hopefully, well, we should have been able to turn that on. Let's just sort that out. I'm going to have to set you down. Have a look at some of these lovely old electronics. There we go. Neutrals in. We have power. I'm actually going to turn the overhead light off because this looks gorgeous when it fires up. You'll see these old rectifiers waking up. Isn't that absolutely beautiful? And as this is waking up, I will overlay the data on. I love those. I don't know how many hours this thing has on it. It's really not a lot. And you can see we've got data exchange taking place down there. Let me just pop the lights back on. And I'm going to do a good deep dive into this thing. It's an absolutely gorgeous piece of equipment. As I said, I don't think it's got many hours on it, and I really do love those rectifiers. Right, I should have been able to overlay a fair amount of data on, so I'll stop here and we'll go and see if this worked. Take care. Bye.